Today we start differentiation under integral sign. What is the application of DUIS? DUIS is an effective technique used in evaluation of real definite integral. It allows to interchange the order of integration function depends on variables as well as parameter. The formula for the DUIS I of alpha is equal to a to b f of x alpha into dx. Then di by d alpha means differentiate with respect to alpha a to b dou f by dou alpha into dx. Here f of x alpha is a continuous function of x and alpha is a parameter. Dou f by dou alpha is a continuous function of x and alpha is in the interval a comma b. Means you have to identify the parameter. If the integration with respect to dx, then other than the x, that value is represented as a parameter. Here alpha is other than x, therefore alpha is a parameter. Then what is the concept? Then total differentiation di by d alpha. If the total differentiation under the integral sign, it becomes the partial derivative. Then dou by dou alpha of that function, dou f by dou alpha means differentiation of f with respect to alpha, treating x as a constant. Let us take the one problem. Example involving one variable, one parameter. Example involving one parameter. Prove that 0 to infinity e raised to minus alpha x sin x upon x is equal to cot inverse of alpha. Here then you have to identify the function integrate with respect to x. Integration with respect to x, then other than x is treated as a parameter. Here alpha is a parameter. Let us denote I of alpha is equal to 0 to infinity e raised to minus alpha x sin x upon x into dx. Then applying the DUIS, apply the DUIS, then differentiate with respect to alpha, di by d alpha, take the partial derivative of this function. Here sin x upon x is a independent of alpha, then integrate with respect to differentiate with respect to alpha, e raised to power alpha x. What is the derivative? E raised to power alpha x into minus x. This x and this x get cancelled, then the answer is minus e raised to power alpha x sin of x dx. Then minus outside 0 to infinity e raised to power minus alpha x sin x into dx. Then using this formula, you know this formula, the integration of e raised to ax sin of bx is equal to e raised to power ax upon a square plus b square a sin of bx minus b cos of bx. In this integral you have to identify the value of a. What is the value of a? A is alpha and the value of b, coefficient of x, is 1. Means a is alpha and b is 1. Formula is e raised to ax upon a square plus b square e raised to power minus alpha x upon alpha square plus 1 in bracket a sin of bx. What is the value of a? A is minus alpha sin x. What is the value of b? 1 minus 1 cos of x. The limit is 0 to infinity. E raised to power minus infinity is 0. E raised to 0 is 1. Then substitute the value. You get there are total 3 minus sign. Di by d alpha is equal to minus alpha square upon 1. Then on integrating with respect to alpha, I of alpha is equal to minus tan inverse of alpha plus c. Put alpha is equal to the 0 in equation number 1 and equation number 2. Which is equation number 1? This is equation number 1. This is equation number 1 and equation number 2. This is equation number 2. Substitute, put alpha is equal to 0 in equation number 1 and 2. Substitute in equation number 1 I of 0 is equal to 0 to infinity sin x upon x. But this is a standard formula, 0 to infinity sin x upon x into dx. The answer is pi by 2. Then I of 0 is equal to the substitute alpha is equal to the 0 in second equation. I of 0 is equal to minus tan inverse of 0 plus c, then 0 plus c. What is I0? I0 is pi by 2. Substitute here, c is equal to the pi by 2. Then I is equal to minus tan inverse of alpha plus pi by 2. Therefore, I is equal to pi by 2 minus tan inverse of alpha. You know the formula, I is equal to cot inverse of alpha.